The last little part of our modern physics is what's called the standard model of particle physics. It turns out that even protons and neutrons can be broken down into smaller things. And it can be broken down into quarks. And all matter is made up of quarks and leptons. Okay, and they have very strange names like the up quark and the charm quark or the tau lepton, but they're things you're going to have to memorize. They're all on the reference table. Okay, so a very simple question actually is, what is a charge on a charm quark? If you look at the reference table, on the charm quark right here, the charge is plus 2/3 of an electron. It's a little strange because we said that you always have to have whole numbers of electrons, but quarks are actually fractions of electrons. Now, combining these particles to make composite particles, because I can't have a quark existing by itself because it has that fraction of electron. So all matter can be classified as hadrons or leptons. Okay. Leptons never combine with other particles. Quarks always combine. Hadrons are made up of combinations of quarks. Baryons and hadrons are hadrons, which are made up of 3 quarks. Mesons are hadrons, which are made up of a quark and an antiquark. Again, you have to memorize it. Also on the reference table. Okay? And that looks like this. Okay? All matter can be classified as hadrons or leptons. Leptons are just single particles. They're not made up of anything else. Hadrons can be baryons if they're made up of 3 quarks, or they can be mesons if they're made up of a quark and an antiquark. So almost all of the problems we're going to be dealing with are just using these charts. So the first question here, what is the charge of an up quark? An up quark, you can just look at, and the up quark, that has a charge of plus 2/3 right here. So the up quark is plus 2/3 E. And an anti-electron, okay? Now the antis, it says this on the chart as well, okay, down towards the bottom. It says for each particle there is a corresponding antiparticle with the opposite charge. Okay? So an electron is minus 1 E. Then an anti-electron would be just like an electron, but a charge would be plus 1. Now, some particle is made up of an up quark, a down quark, and a top quark. And we want to know what type of particle it is. This is its classification, not its name. Okay, but all I need to do is look at this chart here, okay, and see that it's made up of 3 quarks. And anything that's made up of 3 quarks, we're going to call a baryon. And then what's the charge? We just look up each piece of it. So up is plus 2/3 E. Get that from this reference table. And then a down is minus 1/3 E. And then a top is plus 2/3 E. When I add all those together, I end up with 2/3 plus another 2/3 is 4/3, minus 1/3 is 3/3, equals plus 1 E. And you're always going to end up with a whole number, just like we said when we were studying electricity. You always end up with a whole number of electrons. So here's another little problem. Danielle becomes a physicist, discovers a new particle, and she determines it's made up of a top quark and an anti-bottom quark. So if I look at this, it's made up of a quark and an anti-quark, we call it a meson. So its classification is going to be a meson. And then find its charge. Okay, we have a top quark, which is plus 2/3. And we have an anti-bottom. To denote an anti, put a line over the top of it. A regular bottom is minus 1/3. This is going to be plus 1/3. And if I add those together, I get, again, a whole number, plus 1e for the charge. Now, antimatter, remember, they are the same as matter. Okay, but with the opposite charge. So a proton, the mass of it is 1.67 times 10⁻⁴ kilograms. That's something on the reference table. And I know its charge is plus 1e. An antiproton the line over antiproton. Its mass is going to be the same, 1.67 times 10⁻⁻27 kilograms. And its charge is just going to be negative 1e. When matter and antimatter touch, they annihilate each other. Which means both are destroyed. All of their mass is gone. They're turned into energy. So here is an example. How much energy is created when a proton and antiproton touch each other? So the mass of a proton plus the mass of the antiproton are destroyed. So it's 2 times 1.67 times 10⁻⁻27 kilograms. Excuse me, 3.34 times 10⁻⁻27 kilograms of mass that gets destroyed. And then I can figure out how much energy there is, since my mass is in kilograms. E equals mc squared. 3.34 times 10⁻⁻27 kilograms. Equals 3 times 10 to the 8th meters per second squared. I get a value of 3.006 times 10 to the minus 10 joules of energy created when they're destroyed. Now there are a couple things that you do need to memorize. You need to know that a proton is made up of 2 up quarks and a down quark. Okay? A neutron is made up of 2 downs. An anti-electron is called a positron. We'll talk about antiprotons, maybe antineutrons, whatever. But an anti-electron has its own name. It's called a positron, just a positive electron. Neutrinos are baby neutrons. They have no charge, very little mass. And when quarks combine, you have to have an integer.